for significant digits. Do y'all feel comfortable with significant digits? We're not going to get real toothy about it, but it's actually pretty straightforward. However many digits you have given in your problem, that's how many you need to keep up within your answer. So if they give you like 2 digits in everything, like every angle has 2 digits, then your answer needs to have 2 digits. And even, well, if your side is 7, then you need 7 point something, because you got to have 2 digits. You just need 53. And if it was 154, you need 2 digits. So what would you round to? 150, because you need 1, you need 5. You don't, because if you do 154, that's 3. You need 2. Keep it the same as what you were given. So it's, in English class you do parallel structure. It's that mindset. What they give you, you're going to do the same thing. So if they're giving you, if they give you degrees, minutes, and seconds, your answer needs to be in degrees, minutes, and seconds. But like right here, you see you've got 2 here, and there's 1. And there you go, that's a total of 3. And you do count the 0 because there's another number after it. Right, if the 0's at the back end, sometimes you count it, sometimes you don't, and that's where it gets gray. And we'll talk about that. We'll see in just a second. But that would be 3 of them. That's kind of obvious. There's 4, there's 4. Here's the degrees, minutes, and seconds. Let's see here. You see that's 5 of them there? Over here, they did not consider that 0. Because they're going 1, 2, 3, 4, 5. And see, they're counting 5. They didn't count this 0 at the back end. Again, it's just a guideline just to kind of get you where you need to be. Don't press the panic button on significant digits. The main thing is whatever form your problem is given in, you give the answer. So if it's given in decimal degrees, and you need to give another angle, you need to give it in decimal degrees. But if they give you degrees, minutes, seconds, you need to give the other one in degrees, minutes, seconds. So, like Simon says, follow the leader, do the same thing. Okay, is everybody good with this is how you set up a triangle from geometry class? Remember that from way back when? C is always going to be the right angle. Hypotenuse is always lowercase c. A and B are the acute angles, and whatever the side is that's opposite, that's the lowercase letter that matches. So the capital letters are the angles, lowercase letters are the sides. I just wanted to kind of, y'all good with that? That old news? Hope so. Okay. Otherwise, when you look in your book, it ain't going to make a bit of sense, because they're not going to have pictures. They're going to say, what do you do when you got A is 63 degrees, and A is 14, B is 7. And that's all they're going to give you. You got to draw your own picture. Okay. So everybody good? This is what I mean. Can you take that right there and draw the picture and label the picture? Does it matter how you turn your triangle? No, it really doesn't. We're really not in standard position, so this may seem a little weird because we went from everything being in standard position, and now when you're solving a triangle, it really doesn't matter how you turn it. If you want it to remain like you're in first quadrant just so that you kind of keep that feel, then you can turn it this way. Alright, let's see. And C is 12.7. Okay, do you see the little part in red? Oh, I forgot to hit my timer. Uh-oh. just gonna stop it in about 8 minutes. If it says solve the triangle, make sure you find all the angles, all the sides. Now think about it. You have to use Trig to figure out everything. So what can you do? How are you going to figure out angle B, or what would be 90 plus this, so 90 plus 34 degrees, 30 minutes. I got 30 minutes. What's that? Then what? $180 minus that? Would there have been a faster way to do that? Yeah, because what's up with A and B? They're always going to be complementary. So if you want to do the short way, instead of adding that to 90 and subtracting it from 180, we could do the shortcut and subtract this thing. But wait a minute. You having a flashback from first day in here? How did we do that?
Take one from 90.
There you go. We got 89. And then, what's that going to be? 60. Yep, got to borrow. Then you should be ready to go. There's 30 there, and 89 minus 34. 55? Does that sound about right? Okay, so 55 degrees, 30 minutes. Okay, so I have everything. Now, I'll be honest. I like to do it this way. This is just me. I want to make sure I got all my stuff. So I'll list out all my angles, and I'll list out all my sides. It's easy to know what you're missing, what you need, and you can come in here and you can list what you've got. Found this, got this. C is always going to be 90. All right. Now you know one side already. This is 12.7. We have to do trig. Okay. Now here's my word of advice. Take it or leave it, but word of advice. Use the information given to you. That way, if you had made a boo-boo somewhere, you don't compound the problem. Because look, if we had done something stupid, maybe we subtracted wrong, and this is, maybe we did this off, and this is not the right angle. If we use the 55-30 to get one of the sides, that side would be wrong, wouldn't it? Yeah. So go back and use the angle that they gave you and the side they gave you to figure out one of the other sides. So think about it. You were given that. Which side do you want to aim for? Do you want to aim for little b or little a? Little b? Okay, if we're aiming at little b, you want to do cosine. So cosine of A is equal to, how are you going to set that up?
B over 12.7.
B over 12.7. Y'all agree? Everybody good? All right. Looks pretty good to me. How will you proceed?
Is this where you could do the shortcut then?
Uh-huh.
We used to say
But,
12.7.
I mean, and I'll be honest with you, I'm never going to do that. Just slap it over 1 and cross multiply. And that's always going to, when you do that, you're going to see, oh yeah, I just multiply those. But this is going to be the 12.7 times cosine of your angle. Remember what I was saying earlier? If you've got a number, you've got cosine of an angle. So do the number first. So when you come to your
Do you have to
calculator.
convert it?
Well, hold up just a second. We're going to do 12.7 and we're going to type in cosine. How are you going to type it in? Do you have to convert it separately?
12.7 cosine. You say 12 or 34 plus 30 over 1.
There you go. You do not have to do it separate. You can just sit here and do that, can't you? You type it in and do the conversion in the way you type it, calculator's gonna be able to handle it all. Even your baby calculator's gonna be able to rock and roll with that. Now, let's see, how many significant digits we got going on up here? Wait, here, it's easy, right here. 3, right? Because even right here, they're just not counting the 0. So it's 3. So whenever I look at that, I need 3. I need to round 10.5. B equals 10.5. So B is 10.5. Okay. Now you have a choice. Totally up to you guys. You can just be like the Trig master and knock the next one out with Trig. Or you can go sneaky. Pythagorean theorem. Which way you want to do it? Pythagorean theorem. That's the way most people want to do it. So, come in here, you got a squared plus b squared, c squared. We all know a squared. So 10.5, 12.7. I would just go ahead and go to your calculator. You know it's going to be your hypotenuse squared minus that leg squared. Then what do you do with that value? Square root. Square root of, oops, answer. I didn't pick up my answer. There we go. Alright, and again, how many digits do I need? 3. So where do I go? 7.14. So it's not necessarily about how many decimals, it's about how many digits. You want me to do Trig? Okay. Alright.
I did it that way and I got it.
Okay, which, you're coming off of A, and I'm assuming then if you used A and you used your hypotenuse, you went with sine. So let's see here, sine of 34 degrees, 30 minutes equals A over 12.7. Now A's always look like 9, so try to make a point that's an A. Okay. Put that over 1, that should work. Let's see here, 12.7 sine of 34 plus 30 divided by 60.
That's what I got.
What would explain that? I mean, because we didn't do anything wrong here. So what's our explanation for the variation? What would account for, I mean, it's not like we're off by some crazy amount.
10.5 is rounded.
Over here, we used the 10.5, and the 10.5 was not given in the original problem, was it? So of these two answers, which one's better? Why? It's better to use information given. And Pythagorean theorem, this is really, really close. But of the two answers, the trig answer is better because this was given in the problem, this was given in the problem.
So when we take a test, which one are you taking?
I really don't think it's gonna be that much. I'll go through and look at the test generator and see if they actually have a variation that close. I think if you get this one over here, you'll be able to mark the right answer. Typically speaking, this one would be just, this is accepted. This is no problem. But I will print out the test generator and look at it and see. Just to investigate how close they put those things. I would be totally shocked if they put both of these down there to try to trick you up. That'd blow me away. Okay. Normally it doesn't matter which one you pick, but if you really wanted to get kooky about it, the better option is the trig option. Okay, let me stop this recording because I have no idea how long I just went.